Welcome friends to this presentation where we want to see how we can find the invariant line, stretch factor and matrix of transformation from the image and the object, where the image and the object have been given, how to compute these things. Okay, so let's look at an example. So we have these triangles that have been given. Okay, and so you can copy the way they are. You can copy them. You can use a full graph paper. Since this is a full graph paper, all right, you copy them. Okay, please take your time, copy. You can pause the video, draw these diagrams. Okay, so you begin to follow. Then again we have these questions that is not needed. It's not part of take note. It's not part of our discussion. Okay, so you can copy these questions again. This is what we are supposed to do. So these questions are coming from these triangles. We're saying copy the diagram below. All right. So here we are dealing with the diagrams. There are a lot. Diagrams below and answer the questions that follow. So which ones are the diagrams? These are the ones that I showed you earlier on. All right. Then we answer these questions. What is the first question? We are saying triangle. Take note. Take note. Okay, I think it's very clear now. So we are saying triangle ABC is mapped onto triangle A1, B1, C1 by a stretch. So where is this triangle ABC? Okay, I hope we. So ABC is mapped onto this one by a stretch. Have you seen that? Let's find the invariant line. 2, we find the stretch factor and the matrix. Now, to do that, we have a lot of methods, all right? So, what you can do for us to find A. So, if these are drawn already in an exam, then you put your answers in the answer booklet, okay? So, I will say A. This is the 1A. I want to find my stretch factor. I've said we can use a lot of methods, all right? We have been told that this is a stretch. So it means we can try to compare the coordinates. So let's pick the coordinates first of A. All right? Let's pick the coordinates of A. What are the coordinates of A? This is 1, 2. 1, 2. What are the coordinates of B? This is 3, 2. 2, all right? And C, what are the coordinates of C? This is 1, 6. 1, 6. Okay, this is 1. Then let's get the image, A1 or A image. What are the coordinates? This is 4, 2. 4, 2. B, what are the image? What is the image here? What are the coordinates? 12, 2. 12, 2. Then this is the B image. C image, what are the coordinates? This is 4, 6. 4, 6. All right? Now, when you compare, you realize that the coordinates of Y here are unchanged. All right? Then it means the invariant line is parallel to the y-axis. All right? Or it could be the y-axis, because that's why you're seeing the pool is going this side, because the pool is always perpendicular to the invariant line. So actually, because these coordinates of y have not changed, then the invariant line is the y-axis. So the invariant line is the y-axis. So here where you are supposed to state the invariant line, we are saying the invariant line is the y-axis, or x is equal to 0. Then you have found that one. Okay? Then you have found that one. Okay? Then we go to B. B. State the stretch factor. So we are going to say stretch, which is k, is equal to, I can pick 1 point and its image. Alright? This one and this one. So here you are going to say, for you to find the scale factor, earlier on in the first presentation, I think I can show you what we talked about. We said find the scale factor. You can say distance from the image to the invariant line, distance from the object to the invariant line. Okay, so this is what we are talking about. So what we are going to do is, I will say, okay, so the distance, so the invariant line here, it is the y-axis. All right, so if you look at A1 and this one, the distance of this one from here is 4. The distance of this point from there, it is 1. Or you just use the coordinates. You just say 4 divided by 1. All right? So you say 4 divided by what? 1. What is the answer? It is 4. Okay? If you want, you can say 12 divided by 3. It is 4. So that is your stretch factor. All right? Good. So the next question, like I've indicated, we need to find the matrix. The matrix. All right? Need to find the matrix which maps triangle ABC onto A1, B1, and C1. Now, there are these well-known matrices that you might need to take note of. They might help you a lot, which we are calling stretch matrices. So, if you have an invariant line, that is the x-axis, or y is equal to 0, with the stretch k, this is the matrix. Okay? If you have the invariant line with the x is equal to 0, or the y-axis, this is a stretchy matrix. Alright? So, in this case, what was our invariant line? What was our invariant line? Let's take note. Okay. Take note of the invariant line. What was our invariant line? The invariant line is the y-axis, or x is equal to 0. So if your invariant line is a y-axis, this is what you are going to say. So the matrix should be k0, 0, k, where k is the stretch factor. So you are going to say here, my matrix K should be, sorry, not K, but the matrix. Alright, the matrix should be K0, 0, 1. So take note, when you are dealing with a stretch, here you always have zeros. Alright, you always have zeros. Then you have got 1 and a K. So where the 1 is telling you about the invariant line. So in this case, 1 is here on the y. Well, these are the values of y. So you are being told that here where 1 is, that is the invariant line, which is the y-axis. Here where 1, if you have this kind of a matrix, all right? So your invariant line is the what? The y-axis. So what we are saying is that if you have got this kind of a matrix, 1, 0, 0, 3, all right? And maybe another one, 3, 0, 0, 1. Look, it simply means here, the invariant line here is the x-axis. That is our invariant line. Alright? Here our invariant line is the what? The y-axis, where 1 is. But our scale factor here is what? Our scale factor is 3. Here our scale factor is 3. So where the 1 is, that is where the invariant line is. So we are saying if our invariant line is the y-axis, like we have found here, then This is the kind of a matrix that we are supposed to use. All right, so we are going to have K0, 0, K. So this will be equal to, what is our stretch factor? 4. So I'll put 4 here. So I'll have 4, 0, 0, 1. That's what you're supposed to have. All right? So if you have a problem with the taking note of these matrices, you can use it. You say, oh, we have another method. What is the method? We are saying for us to find the matrix, we are going to say you multiply the required matrix, all right, by the object, so that you produce the image. All right, what are the coordinates of the object? 1, 2, 1, 2, 3, 2. 1, 6. This is equal to A1, B1, C1. All right, you have got 4, 2. Then here you have 12. From here, 12, 2. Then you have 4, 6. All right, so this is what we are going to do. So we are multiplying A by 1, so it will be A plus. This by that, you get 2B. All right? Okay. Then you can say A by 3, you have 3A plus. This by that, you have got 2B. Then A by that one, you have got A plus. This by that, 6B. Okay? Then I come to this one. C by 1, you have C plus. This by that, 2D. This by that, 3C plus. This by that, 2D. C by 1 is C plus. 6C, 6D. So you have got 4, 2, 12, 2, 4, 6. This is another way of getting this one. Okay, what does this mean? You have A plus 2B is equal to the first one here, which is 4. You can pick another one where you have got A and B, maybe this one. So we have 3A plus 2B is equal to, the second one here is 12. So we have got this one. We solve them simultaneously. And you can get another set, maybe where there is C and D. See, you can ignore this. A and B both has already been represented. So we have C plus 2D is equal to 2 here. 2. Then 3C plus 2D is equal to 2 again. Okay? Then you solve them simultaneously. So here maybe we can use the elimination method. We eliminate this, so we subtract. So these will cancel. 2B and 2B will cancel. So you have got A minus 3A is equal to 4 minus 12. All right? Okay, so take note. So we are going to have negative 2A is equal to, here when you say this minus that, you get negative 8. So you divide by negative 2, you divide by negative 2. So our A is 4. Okay, our A is 4. Take note. Then what is our B? So we can get this one. We have A plus 2B is equal to 4. Our A is 4. So we have 4 plus 2B is equal to 4. So we take 4 the other side. So we have got 2B is equal to 4 minus 4. We divide by 2. We divide by 2. Okay, B is equal to 4 minus 4 is a 0 divided by 2. So B is equal to what? 0. So we have found A and B. So we can go to C and D so that this matrix is found. A, B, C, D. So A and B have been found. So we come here. Again, because these are the same, we can eliminate them. We subtract so that they cancel. Right? So you have got C minus. Take note here. This is not A, but C here. Take note, this is C. So here we need to put C. It's not A. Okay, so So we are going to say C minus 3C is equal to 2 minus 2, okay? Here when you subtract, you get negative 2C is equal to 0. You divide by negative 2 by negative 2. So C is equal to what? 0. So if C is equal to 0, we need to find D. So we can say C, we can pick maybe this equation, this one. So C plus 2D is equal to what? 2. But our C is 0. So 0 plus 2D is equal to 2. So 2D is equal to 2. You divide by 2, you divide by 2. So D is 1. So what are we saying? We are saying A is 4. Okay. We are saying from our calculation, saying A is 4. That's what we found. Then we found B to be what? 0. C, we found C to be 0. So C is 0. D is equal to what? D is equal to 1. So we said the matrix should be A, B, C, and what? D. This is the matrix. Okay? Now, you say, what is our A? 4. Our B, 0. Our C here, it's 0. This one. So this is your matrix, which is exactly the same like this one that I mentioned earlier on. Say, if you know the matrix, take note, this, you just substitute. But if you have a problem in knowing this, then you just solve them like we've done. Okay? Solve them like we have done. Okay, so from here, I hope it is okay. Hope it is clear. We went like that. I hope it is fine. So this is our final answer. So it means 1A has been answered. So the procedure is the same. Okay, so we go to question. The next question is question I think 2. So now I'm going to question 2. Question 2. So we are saying this triangle XYZ is mapped onto X1, Y1, Z1 by a stretch. We find the same. So it's the same. It's the same. Okay. So this X is mapped onto this one. Okay. This is mapped onto that one by a stretch. So the first thing is we get the invariant line. We need to identify the invariant line. All right. So you can do the same. We say, what are the coordinates of X? Okay, so you say X. All right. Okay, so we are saying for us to find the invariant line, we can even use these coordinates. We find the coordinates of X. So when you check here, you have negative 6, 2. For Y, negative 2, 2. For Z, negative 6, 4. These are the coordinates that I have written here. Even for the image, X1 is negative 6, 6, which is this one. Y1 is negative 2, 6, which is what I've written. Then that one. So we can even use these to compare, right? To find the invariant line. So when you check here, there's 6, there's 6, there's negative 2, there's negative 6, negative 6. It means this implies that the x-axis is the invariant line, or y is equal to 0. We are done with that one. Then we go to B. B, we need to find the stretch factor. All right, the stretchy factor. So the stretch factor which is So we can pick one point. The values are you look at the coordinates or the values of the axis that have changed, which is in this case maybe we pick x. So we can say x1 divided by x. Okay. So when you look at x1 here, y1 and y here, because this is y. So you have 6c divided by what? 2. Okay, what do we get? 3. Even if you say 12 divided by that, so this is our scale factor. So the matrix, you can apply the same approach, or you go to you use this to say which one is our invariant line. We're saying our invariant line is the x-axis, so I'll apply this, I'll use this, because the invariant line is the x-axis, so you're going to say 1 0 0k. All right, so matrix is 1 0 0k. Okay, so this will be equal to what is our stretch factor? 3. So this is the matrix. Alternatively, you can apply this method. You solve them simultaneously, you'll still be able to get that answer. All right, then we go to the next question. If a toy is different, so we go to question 3. So question 3 is saying triangle PQR is mapped onto triangle P1, Q1, and R1 by a stretch. Find the invariant line, stretch factor, and the matrix, which is exactly what we are doing. So this one, I'll say do it yourself. All right, this one, do it yourself. You can try this one. It's like your task. All right, you can try this one, but the approach is the same. So that we go to question 4. Okay, question 4. What is question 4 saying? So you need to take note that by PQR we mean the same diagram that you'll have already drawn, which is this one. Okay, so this is mapped onto that one. So you find the invariant line, stretch factor, and the matrix. Okay, so we go to the next one. Describe for the single transformation which maps triangle ABC onto A1, B1, all right, and C1. Okay, so there are 2 questions here. Okay, there's A and B. You triangle A1, B1, a triangle ABC onto this one. What kind of transformation? All right, then this one. So 4, again, I'll do A. Then since the second one is talking about PQR, which is the third one, again, this one you are going to finish. So maybe B, again, I'll say do it yourself. All right, so let's look at 4A. They are saying triangle, describe fully the single transformation which maps triangle ABC onto triangle A1, B1, and C1. Triangle ABC onto what? A1, B1, and C1. So this is a stretch. So when you see that it is a stretch, you write that it is a what? It is a stretch. What else do you need? You need to state the invariant line. And if you remember what we did the first, well, this was question 1. We already found the invariant line, that the invariant line is the y-axis. But if you are doing it for the first time, we are supposed to find the invariant line. So in this case, invariant line is y-axis, is our invariant line. Also, you need the stretchy factor. So if this is the y-axis, the invariant line, all right, you can pick C1 and C. So the distance of C1 from the invariant line is 4. This one, C from the invariant line is 1. So 4 divided by 1, it is 4. Actually, even this one, we already found it here. All right, we already found it here. But if you are doing it for the first time, you're supposed to find it. So the stretch factor K is equal to what? 4. It means you have fully described that one. Alright, so that's how you're going to do that. So for your exercise, you do question 3 and D for B. Alright, question 3 and 4B. Thank you so much.